Factorial is a shortcut notation to indicate the product of the first n positive integers. Factorials are denoted by n with an exclamation sign that follows. And factorials are defined in the following way. We define 0 factorial to be 1. 1 factorial is also defined to be 1. And n factorial is the product of the first positive n integers, so it is the product 1 times 2 times 3 times 4 times and so on until we reach a value of n. So let's look at some examples. 5 factorial is going to be 1 times 2 times 3 times 4 times 5. We multiply first positive integers starting with 1. Notice that these are consecutive integers. And this product, when computed, amounts to 120. Similarly, 9 factorial is the product of the first 9 positive integers starting with 1, so it's 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. And if we do that multiplication, we'll end up with the number 362,880. If you look at this long product, you can notice that that product contains the product of 1 times 2 times 3 times 4 times 5, for example, which is the 5 factorial. So 9 factorial can be written as 5 factorial times the rest of the factors that will give me the 9 factorial. There was nothing special with the number 5 that we chose. We can consider the product of the first 7 numbers, and that's going to be 7 factorials. So we can also write that 9 factorial is 7 factorial times the remaining factors. And this is property for any factorial. So we can write n factorial to be k factorial times the remaining factors, which will be next number after k, which is x plus 1, then the number after that, x plus 2, and will continue until we reach the number n. And this can be done for any k that is less or equal than n. So for example, 10 factorial can be written as 8 factorial because 8 is less than 10. And then we have to multiply it by the remaining factors, so it's going to be 9 times 10. Using this property, we can evaluate some expressions that contain factorials. For example, 8 factorial over 5 factorial. Instead of multiplying the numbers from 1 to 8 and coming up with the number for 8 factorial and 5 factorial and then dividing, you can use some algebra to simplify those expressions. Since 8 is more than 5, we can rewrite 8 factorial as 5 factorial times the rest of the factors would be 6 times 7 times 8. And the denominator will leave it as the 5 factorial. So since we are dealing with the product, you can see that 5 factorials from the top and the bottom will cancel out and we'll be left with only 6 times 7 times 8, much smaller product to evaluate, and if we do that, we'll end up with 336. In similar way, we can evaluate the expression 11 factorial over 4 factorial times 7 factorial. Now, if you look at the denominator, the larger number between 4 and 7 is 7, and therefore we'll break up 11 factorial as 7 factorial times the rest. So it's going to be 8 times 9 times 10 times 11. And we leave 7 factorial intact because we will be able to cancel as the example above. And the 4 factorial will rewrite as 1 times 2 times 3 times 4. So 7 factorial will cancel out. Now we can also do some simplification among the numbers that are left. For example, 8 and 4 will simplify. The 4, we divide both by 4, so we'll have 1 here, but from 8 we'll get 2. And now we can simplify 2 in the numerator and 2 in the denominator. The same we can do with 3. 3 and 9 will simplify, leaving 3 behind. And therefore, this expression reduces to 3 times 10 times 11, which is simply 30 times 11, and that is 330.